So sometimes when you're doing these things, this is kind of mixed together. What I want to look at today is how do you write equations? Thanks, Felix. So what I want to do is look at how are we going to write out equations given specific information. Well, so when you're looking at some of this stuff, as we build these things out and we're looking at, well, I need to know whether I'm going to be a sine or a cosine or a tangent graph when I'm just given information like this. So if I'm looking at an amplitude of 10, a period of 4, I don't know if it's a sine, cosine, or actually, I know it's not a tangent because the tangent have a technical amplitude.
Oh, no.
No. So I know it's going to be a sine or a cosine. So I need to know which it is. So if I give you this, I would tell you sine graph with a greater than 0 and b greater than 0. To alleviate any misconceptions as far as is it opening up or down or whatever.
So there's no way to actually figure out from just amplitude period sine or cosine?
No, you need to see something else. And you can do that from a graph. We can figure that out, but not from just that. So I can do either one where it says sine or it could say cosine. So let's say it's a sine graph. And obviously in this case here, there's no phase shifting. There's no left or right shift. There's no vertical shift. There's no nothing. It's just amplitude and period. So I'm going to write the equation of y equals a sine b of x given that. Well, if amplitude is 10, what's my a value?
10.
All right, we're halfway done. Now, go back to this b value, this period. Remember, the period of a sine or even a cosine graph, the period is 2 pi over b. I know that the period is 4 equals 2 pi over b. What's b?
1/2 pi over 2.
Pi over 2.
B pi over 2. Remember, when you have stuff on the diagonal like that, all you have to do is switch them out. B is going to be 2 pi over 4, otherwise known as pi over 2. Yeah.
So, I mean, I get that like the amplitude is A, but isn't amplitude the
Absolute value.
yeah, absolute value?
And
So could
this,
it be negative?
this is why we write.
Oh,
Yeah.
okay.
Okay. And that's a good question. And that comes up when you see that, it'll say, hey, A is going to be positive, B is going to be positive, to alleviate having to worry about the plus, minus, and electrical charge. Okay. So here you've got a B value then of pi over 2, so your equation is 10 sine.
Oh, that's not all we're doing today. I know it's not.
Yes, sir.
How did you know it was sine?
I told you to. What? DC caught that. What about the second one?
What about
Let's write the equation for the second one. We got the amplitude of 2, a period of 2 pi.
Still sine.
It's still sine. Still sine. Well, we know what A is. What's B? Done.
Next problem.
Okay. Yes, sir.
I know you wrote it in the last problem that A is greater than 0 and B.
It'll be given, yeah.
All the time?
Yeah.
And it'll tell us whether or not it's sine or cosine.
Yes. Yes. Graphically, you're on your own. Sir.
Isn't
assume that A is greater than 0?
No, so it would
Be negative.
Or wouldn't the amplitude be so negative? Oh, that's right, yeah, sorry.
Ooh, feisty over there. Take that. Hey, look, it says the graph of 1/2 cosine pi x. So what kind of a graph is it?
Graph.
It's a cosine. Why is that? Because it says so. So 1/2 cosine pi x is translated down three and a half, or three halves, and left 1. And reflected about the line, -3/2.
Yeah, that last part kind of screwed.
So think about the parent function itself of 1/2 cosine pi of x. That y equals 1/2 cosine pi of x has an amplitude of 1/2. It has a period of 2. You okay with that?
Yes.
So if I graphed that, it's 2 pi over b. Our b value is pi.
Oh, it's the
Don't go off on this. Ooh. Know what your face is. Sorry. Anyway, so not sorry. We have a cosine graph. It's going to go through. The cosine always starts where? A. It's going to go through A. It's going to cycle through the other 4 points. It's going to end at 2. Halfway is 1. You have 1/2 here, and you have 3 halves here. Everybody okay with that?
Yes.
Real fast one. So this goes boom, do, 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 and we do this. All right. They give you an eye patch? We should make you an eye patch. Did we make an eye patch for somebody here?
Maria.
Rest in peace, Maria.
Well, she's in 4-5.
Right.
She died.
Anyway, look at what the shift is saying to do. At this point, they're saying it's moving down 3 halves. So is this an H or a K value?
That's a K.
That's
value.
Vertical.
Oh,
Okay. So right now we have this to start with. We have y equals 1/2 cosine. It has to move down 3 halves. It also says to move left 1. If I move left 1, is it going to be a +1 or a -1? +1. So this is my new equation. Okay.
Yeah, that's what I was gonna ask.
Well, here's what I want to show you. Why is it reflected? What happens here is that you're going to move this down 3 halves. When you move something down 3 halves, here's 1/2, 2/2, here's 3 halves, so it'll be at -1. Everybody okay with that?
Yeah.
Each of these points, so we have -1, -1.5, and -2. We all right with that?
Yeah.
If I'm moving these down, oh, we have to move left also. Let me just move them down first, then I'll show you why it's being reflected, how that reflection thing works. Yeah. It's doing this, but it's flipping it over that axis.
So it's just making A negative.
It's just making A negative. It's flipping it. It flips it. When you see it reflected over an axis, it's just making your A value negative. That's all it does. That's all it does. So even though you guys were saying, oh, I'm not sure what to do with this reflected above the line, y equals a number is a horizontal line, isn't it?
Yeah.
Yeah.
Yes. Y equals a number is a horizontal line. If you're taking your graph and you flip it over the line, you're just making a negative. That's all it means.
What if,
That's it.
what if it's over the, like, vertical axis?
Then it's going to be a tangent graph.
Oh yeah.
Because tangent goes vertical. If you flip it over the line like x equals 2, then it means that instead of going up, it's doing that then. Okay?
So we're never gonna flip cosine and sine over.
What we just did?
Oh, I mean over x. Like
No. You don't have to worry about flipping cosine and sine because then it's just all sorts of, no.
It's possible. Isn't it?
We're not going to do it though.
Okay. Good.
I think well, no, because it's continuous, and if you flip it over a vertical,
I mean, you flip it over, but it doesn't really do anything.
yeah, I don't think it, yeah. I don't know how you would write that.
Okay.
All right? Yes, sir.
So are we always gonna reflect it over the center of it?
It's just making a negative. Yeah.
Never.
And the reason why we do it over that line, and this comes from why we can write these equations out, especially if you're given a graph. When you're given a graph and you're thinking about sine and cosine, if I look at just a generic sine graph, if I look at just a generic sine graph, I know that sine starts at 0, moves its way up, and does this. Okay? Versus a cosine graph, that does that. What I want you guys to notice is that in a sine graph, how many values share the same y value? 3 of them. In a cosine, there's 2. Actually, 2 sets of them. Okay. So when you're looking at a sine graph, to be able to identify whether or not it's a sine graph versus a cosine graph, you're looking to see how many times you share that same y value within a cycle. If you figure out the cycle, then you can tell whether or not it's a sine or a cosine graph. Does that make sense?
Yeah.
Ah, what if it's shifted?
Okay, whatever it is.
But what I'm saying is that, what if it's shifted and it's up and through? What's that?
Because like they look different.
They do look different, but what happens if I put in more than one period?
Show us.
I had to reboot my computer. I lost all my open files. I can go back to it. Sorry. Just have this on here. Just save There it is. Take a look at this. Sorry, I actually have that copy of this. Let me give you guys this copy. Needing to identify what the graph is here. It's on the, like one of the last pages here.
Can you have cotangent graphs and secant cosecant graphs?
Yeah, we're gonna do that next week. We're gonna do that after we take our test.
Do you have
Okay. Now, I'm still looking at testing this stuff Tuesday. It's my best. It's still kind of what I'm thinking. what I'm giving you guys here is got, the only thing that's not on here is your simplify verify. And we'll talk more about that stuff Monday as well. When I'm looking at this problem itself, first thing I'm going to try to figure out is is it going to be a sine or a cosine graph? Notice they're only giving you one cycle, going up, down, and back up again. I go through the same points 3 times, which means it's going to be what? It's going to be a sine graph. This has to be a sine graph because it touches the same 3 points on the y value. Okay. Isn't a cosine graph a sine graph shifted 90 degrees? Yes, sir.
Wouldn't it also be a sine graph because it starts with
True, but what happens if you've been shifted? Yes, sir.
Wasn't those hyperbolas where it's like n minus 1 for like the coefficient or whatever it was is equal to how many times it goes across the x-axis, or what was that I'm thinking of, where if you had the polynomials and let's say you had a to the 4th, yeah, then you have it where you'd have 4 solutions.
Oh, I see. Yeah, you have force of 3 changes in
Yeah,
direction.
3 changes in
Yes.
direction,
Yeah. Yeah, that was for the polynomials. So this is a little bit different. These are trigonometric. Okay.
So that is nothing to do.
No, but it's good. Good. I'm proud that you remembered that, though. That's awesome. I forgot about it, to tell you the
Because I
truth.
was just thinking that cosine one looks like the parabola,
Yes.
how it just dipped.
Right.
And so I was thinking this one looked like, whatever was the hyperbola or whatever you call it, where it had the change of directions.
Oh, the cube.
Yeah, I don't know. Whatever it was, that's what I'm thinking.
Yeah, I see what you're saying. Yes, because you're right. The cube one did that.
Yeah.
Right. Mhm. Yeah, good way of thinking. I never thought of it. It had 3 solutions. Yeah, so it's a cubic function. I see where you're going with that. So in this case here, yeah, Jonas.
What keeps getting me is this is supposed to have something to do with triangles, right? Trigonometry, triangle, like.
Yeah, true.
Yeah, it's all based off the 2 special right triangles.
That bugs my life. That, like,
So in this case here, what is your end point? Pi. What's your starting point? So that means your period here is pi. So what's your b value? Very good. Now, did this graph go up or down first? So your a is positive or negative?
Positive.
What's your a value? 5. The reason why we know that it's 5 is because it's 5 above and it's 5 below from the constant horizontal line. Correct. All right. So your a value is 5. Has this moved left or right? Obviously no, because it's starting at the origin, it's ending at pi. There's no shifting going through this one here. So my graph would just be y equals 5 sine 2x. On that sheet there, it talks about something called phase shift. We call the horizontal shift phase shift when you're in pre-calc. Hence why the header on that thing says pre-calc 4.5. Because there's an H in there. Look at number 2 now. Look at the second one. The second one's a little bit different. The second one is different in so much that it has more than one period drawn in here. And there's some shifting going on. That was good.
Can you write that on the window?
Anyway, now, does it say that this is a sine or a cosine graph?
No.
So could it be either?
Yes.
No, it's cosine.
Why do you want to go cosine, Dios?
Because it's only okay. Can I like go up there?
Yeah, show that.
Oh my gosh,
I can't talk.
he did this every day last year.
Okay. Because it touches it different points here as like 2 pairs,
Okay.
and then the other 2 would be like right.
You notice that it's weird logic.
I'm not wrong though, am I?
Yes.
I know where you're
I see
going
what
with
you're
that.
saying.
I know where you're going with that. And you could probably think of it even easier.
Okay.
If you're going to go think about it in terms of cosine,
Wait.
where does cosine always start?
At the well, you said what if it's shifted?
Right. But if it's starting at an A, I see where you're going with that. But I see how you have the 2 spot here, you have the 2 spot there. So yes, we'll go with cosine here. Well, go with cosine. Now, if you're saying that, this one drops down to 1, but it goes up to 3.
So that means that it's been shifted.
Where, it's been shifted where? What direction? Up. What's the line that it's,
2.
it's shifted up 1 from
2.
2. The original start line should have been at, what was it, 2. Because if you had this, it would go up to 2, it would go down to 2, and it would done whatever, but it's all been moved up 1. That way there's this imaginary line through 0 that's equal above and equal below. It moved up. Yes, sir?
But how do you know it just went up? How come it couldn't be a spot to the left on the bottom right over there?
You could have chose that as well.
So you can do any shift that would work?
As long as it's written out correctly, yes. Because there are multiple ways. I could have written this as a sine graph. I could have done this as a sine graph that's been shifted left pi over 2.
So,
And it had it gone through like that as well.
so you can do it however you want as long as it works.
Correct.
Okay.
Because remember, sine and cosine graphs are only 90 degrees apart. Yes, sir.
Since a point is infinitely small, couldn't that mean that there are infinite solutions because you can't keep landing on a single solution?
I know where you're going with this, and yes, there are multiple solutions. Because you could even say that it's a negative. You could have said it's a negative A value by moving downward first on a right sine graph, by moving down first, then up and down, by having that be its endpoint. You could say it's a negative cosine graph because it started here and worked its way up and then down. There are many, many different ways. It's what do you see and what can you say about it? It doesn't work. Yes?
So when it's shifted, you have to solve it, you have to get the point that you're starting down on the 0, on the origin.
Yeah, it's easiest to start it off with the origin and figure out where it went from there.
Because like the place you're talking about is starting from 2. How could you move? Could you say it shifted 3 up from the origin?
No, because if it was shifted 3 up from the origin,
Oh, I see.
then your original point would have been at 1 and 1. If I go up 1 from here at 3, it'd be 4. And if I go up 1 from -1, it'd be at 2.
Oh, I see.
So you have to think about the pairing of it. So usually it's easier to think about between the top, the peak and the valley are equidistant from the same horizontal spot.
And then
Get the
that
average.
should be the origin.
That's your K. So your shift K, and then build out of that. Okay? Yes, ma'am.
So there are many solutions.
Yes, ma'am. Yep. Now there would be less solutions if it looked like this. Putting me on the spot.
Did you see that guy that solved that problem?
Yeah, I saw that.
Yeah.
You could have done it.
Oh, yeah,
I still
yeah.
don't get that problem.
I don't even know what it
It was
means.
like a squared plus b squared equals c squared.
Well, it was like,
No, it was
x to the n plus y to the n equals z to the n.
And then.
But you have to solve for n.
It's like no integer is equal.
Yeah, no, it's also an integer that's above 2.
No integer that is greater than or equal to 3.
Take a look at this.
Yeah, which is above 2.
Wait, what was
But I don't see how you're supposed to solve for n.
So what happened here is I tried to come up with something really fast, and I don't know how well it actually works, but is this a, first of all, is it going to be a sine or a cosine graph? Why is it a sine graph? I got 3 spots, okay? The original non-shifted part here touches 3 spots, so I know it's got to be a sine graph. My A value is positive or negative?
Negative.
Why?
It goes down or it goes up.
Good. How much did it go down?
2.
How much did it go up?
2.
So what's your A value?
2. Negative 2.
Okay. I started at 0, I ended at 5 pi over 8. So my period is 5 pi over 8. So 2 pi divided by 5 pi over 8 is,
You know.
16 times.
so my B value is 16 pi over 5. Look at the 0 and look at the point. All right, first of all, does everybody agree that it went left? So it's going to be x plus or x minus? Plus.
Plus.
Look from the 0 to the next part, the furthest left part.
Negative pi.
So it's going to be x plus 5 pi over 16.
Mr. Murphy,
Yes, sir.
what happened to the pi in that equation? There were 2 pi's there, and I don't know, that's confusing for some reason.
Oh, did I? Yeah, it should be just 16 fifths. Excuse me. Thank you.
Okay.
Yeah, it's supposed to be just 16 fifths, guys. Sorry about that. Okay.
That was confusing.
And then, where is the new 3 dots located on the y value?
2.
At 2. So this should be, sorry, this should be up at, this should be 4. So it's plus 2. In this case here, in order to identify a full-on shift, H and K, you have to have parent and shift.
So we have to get the parent function.
What's that?
Do we need to find the parent functions too?
No, because you use the parent function to develop the rest of it. Okay?
I thought it was already given.
Yeah, both those graphs should be given to you. Write the equation. Whereas the ones that are on here, it's kind of difficult to tell where it's been shifted. That's why, like Mr. Williams was saying, there's infinite many different types of ways of writing that out. It's kind of a crapshoot to figure it out. So you kind of work with it a little bit. In this next one, on 3 here, it's telling you to use sine as the parent function. I'll actually use cosine there. I didn't read that instructions. We should have done cosine for the other ones, but whatever. Not following instructions. Go figure. A teacher. Ha!
Well played.
Yeah, it never happens. I know. But the last page tells you some cosine ones. You should. Oh. So that's the idea, guys. Can you look at given information to develop out of the graph by slowly going through it chunk by chunk? Now, when it gets down to the whole test thing, like I've said before, it's 14, so it's going to be 14.3, 14.4, and then the graphing. 14.3 is your verify, simplify. 14.4 is your solve the equations. And then the rest of it is this stuff. Yes, sir?
You should have an extra credit one where it's like, it was confusing like the one we did before. And see whoever gets, or not whoever gets, like, if we have reached a certain number of solutions that we find for it, and we get extra credit points. Like, you know what I'm saying?
I know what you're saying, yeah.
Really hardcore
Extra
extra credit
for those.
questions.
Good. It's extra credit.
Take home extra credit.
Not doing it.
Christina, you would just be like, hey Victor, do this for me.
Victor, next one is differently interaction.
Or you'd be like, hey Misha,
Yeah,
when I
that's
come to
true.
Chicago next.
So when we go through this stuff, the stuff that I gave you guys here today, it's got a whole bunch of equations and junk on it. The very first page, I forgot to write down on the instructions. Do the left column. Do the left column as general solutions, and do the right column as within one revolution. Okay? So the left column, the left do general solution, the right do your interval. So let's spell the word general. G-E-N.
As opposed to.
There's no N in the interval notation. So in general, there is an N. I am using this as interval notation. Yes, I know there's N's in it, but you see an N in that symbol.
No. Yes.
No.
I'm freaking out.
Yeah, the pilot's like an
Or you could have like the two if you write it the other way.
I'm so confused.
Let's walk through a general solution then. 3 minus 3 cotangent theta equals 6.
Oh God.
Divide by 3.
Can't do that. Subtract 3 first and then.
Divide by negative 3.
So, what's 6 minus 3?
3.
Where are we? There we go.
What's 3 divided by negative 3?
Negative 1.
Cotangent is the inverse trig function of
Tangent.
So reciprocal property. This means tangent of theta is, what's the reciprocal of negative 1?
Negative 1.
Where is tangent negative 1?
135 and 350.
I don't know anything about these degree symbols you're talking about.
I don't like radians.
Well,
3 pi over 4 plus n pi n.
Yeah, 7
so we have 3 pi over 4 and 7 pi over 4.
And then you can add.
They are the same distance apart.
Yeah, you can do 3 pi over 4.
So your answer is 3 pi over 4 plus pi n.
Time out. What? Negative 3.
It's called incoming.
I flip tangent. Does that make it positive? Does that make it positive 1?
What's reciprocal of negative 1?
Oh, negative 1.
Well played.
Same deal when you look at interval between 0 and 2 pi. The only difference is you're solving for all angles that give this answer. Add 2. Divide by negative 1. Cosecant is the inverse of what trig function? Sine. What angle has a sine of negative 1?
Pi over 2 and 3/4.
Good job, Sandy.
Go to the next problem. Yes, sine and cosecant you can have, remember sine is between negative 1 and positive 1.
Oh, 90 degree. I'm forgetting about 90.
Quadrantals are important. Yes, sir.
So I'm sure you've explained this to us before.
No, I skip everything.
Yeah, you're right. So why is it that we do stuff in radians and not in degrees?
It's the way that everybody else does it. It's the way you do it above this class is what you do.
Got a second question. How does everything fit inside that box?
It's the terms of, wouldn't everything always fit inside of the box if the box was infinitely large?
But it's infinitely small because it's made up of points, which are infinitely small, that are connected by lines, which are infinitely
But
thin.
wouldn't
On a
everything
plane,
else, wouldn't everything fit in something that's infinitely small?
Stop it, stop. I'm not figuring out.
Technically, it's not infinitely small, but it's infinitely thin because it's two dimensional.
The other one I wanted to look at.
Just kidding, Mr. Murphy, shouldn't it just make 3 pi over 2?
Technically, that drawing is three-dimensional.
Yes, thank you, you're right. Chimkey.
But everything would
Yeah, but
happen
I
in
gave you
that.
the answer the first time.
It's supposed to be just at negative 3 pi over 2. Sorry about that. Because it's negative 1, not both plus or minus 1. It's negative 1. Where is sine negative 1? Sine is negative 1 at 0, negative 1. Up here it's 0, positive 1. Sorry, I overlooked it.
So then if it was a general, you do 3 pi over 2 plus 2 pi, it's pi, 2 pi.
I would try and work through as much of this as you guys can. Come Monday, I'm going to answer a bunch of the questions, do some graphs, write some equations, do a couple more verify, simplify problems for you.
And then we're
And then
gonna
we're-
put it in.
No, that's great study stuff, man. It's great study stuff. And then on Tuesday, we'll take the test. Wednesday, we will work
Wait,
on...
don't we have that author thing Tuesday?
I don't know.
Okay, I heard something about an author thing.
I hope you skip it.
Wait, what?
I'm pretty sure I thought there was an author thing Tuesday.
That's
but it
for
might be
Humanities 3.
Yeah, I'm an AP Humanities 3.
Well,
I'm gonna skip it. I'm not gonna.
I was going to say, I hope.
No, I was just curious.
I don't know. I honestly don't
I thought
know.
it was mandatory. Like everybody's doing it.
I don't know.
I'm not.